Okay, welcome back students. So in the previous class we have done the insertion in the beginning of a list program. Okay, that algorithm program is already done. So in this class we have to be study insertion in the end of a list. Okay, suppose I give you the first of all concept. Suppose this is a list. Okay, start pointer contain the address of first node. And that suppose we take 4 node, right? 4 node. Okay, this is null. See, this is the memory address. So 1001, 1003, 1005 and 1007, right? We declare it is a singly linked list. You see, so this start will store this memory address 1001 and it will store this memory address, it will store this, next memory it will store this, and this is null because there is no node after that. So we take some elements, suppose 11, 13, 15, 17. This is a complete one singly linked list, right? So what we have to be insert a new node in the end, means in the last. Previously we have to be insert a new node in the beginning. That will be done already, algorithm program, everything done. I hope you understood. Any doubt you can ask me. So now we have to be study insert a new node in the end in here. So for that we create a node. Oh, this is a node. Okay. We create a node. So memory address is 1009 and information we suppose take 19. This is a node. And why it is take null? I already told you many times because it is now independent. So when we insert that node at the end, so this null will be gone and there is a new node. This coming 19, 1009, it will contain now 1009. See, previously the last node is contain what? Null. Now it will contain the memory address of this because previously what? The list is ending here. Now your new node is added here. Now your list is ending here. Means your new node will contain your new node will contain now null. Means if it independent, it will contain null, and it is if it added, it contain null. This is the difference. In previously, the new node will contain, definitely it will contain null when it is independent. For both cases, when we insert in the beginning or we insert in the end. When it is independent, it is null. But when this node is insert in the beginning, this null part is gone. This will contain this address. But when this node is insert in the end part, then it null will be same because it is also contain null. You see, this will also get null. Got that point? Okay. See, when this new node is inserted in the beginning, I can tell you this null part will be gone because this will be contain this memory address. This second means previously passed this memory address. Means we take this as a save. Okay, this node as a save actually. Okay, we done in algorithm. We done in algorithm program. But when we add this node in the last part, then this null in here, when it is independent, it contain null, right? When this node is independent up to not added, it pointed null. But in the added in the beginning, null will be gone, address there. But when it is added in the end, this is same. This is the difference. Okay, I have understood. So now we have to study the algorithm. Okay, and one concept I told you in algorithm, one concept we defined, that is rare. That's why I first of all told you what is rare. I already told you, if you remember, not front and rear. Rear means, you see, actually mainly this front and rear is coming in Q part. Okay, Q part, but Q is not in for this year. Q is deleted for a syllabus by the council, I already told you. But front and rear main concept is coming in Q, but rear is important part, important concept. This rear concept is also coming in this here, linked list. I tell you what is rear. You see, suppose this is an array, okay. This insertion part, rear takes insertion and front takes deletion. Rear takes insertion at the end and delete from the front. That's why I already told you this Q is what FIFO data structure, first in first out, and stack is LIFO data structure. Last in stack is what? Stack is this. Where you insert, you can delete from the top. My last insert is delete first, that's why LIFO. And stack Q is FIFO. Means rear is insertion, in the rear, insertion takes at the ending part. Means in this linked list, we inserted the list in the last part, means we inserted at the rear position. At the rear position. Okay? This rear is coming in algorithm. That's why I first of all tell you what is rear. None other than we have to be confused. When I write algorithm, you confuse what is rear. How this RER what is coming. That's why I first of all tell you. Means rear is for insertion at the end position, rear position. This position is called rear position. Okay? So now we shall start the algorithm for this logic, insertion at the end. See, insertion in the end of list, okay? Insertion in the end of list, okay? Number one, same thing. declare pointers start ptr new ptr and rear. I already told you rear. So ptr start new ptr is equal for new node if new ptr is equal to null, no space available, aborting, exit. 7 else new ptr info is link will be null. 9 if start is equal null means empty and list is empty, then start is equal new ptr. This is the easy concept. Otherwise rear new ptr. Rear means what? This list is empty means what? Everything will be start last same thing. Otherwise rear link will be new ptr rear link will be new ptr and rear is equal new ptr. And 14 is end. See. You see, we take pointer, how many pointers? Start pointer, start is assuming the ptr means pointer, if new ptr is equal to null, if new ptr is equal to null means if node is not created, I already told you, if node is not created, how you enter added a node in the list, that's why no space available, aborting, exit. Else new ptr link is equal null, okay, and if start is equal null means if the list is empty, then means if the list is suppose like that, if this is the list, okay, then what is happen? If this is the list, then suppose this is a new node, new btr, then start will go on to the new btr and rear is new btr. Rear means what? Insertion position. Insertion also in this is rear means what? There is only one position, na rear. Otherwise, suppose one. Okay, else is not here because but this condition is in the else part. Okay, this condition in the else part. Else is not writing in a book. Otherwise, suppose list is not empty. Suppose this is a list. So this is a list. Suppose this is a list. Then you see rear is here, this is rear, this is rear, okay, this is rear. Last node is just like previous, we take first node safe. In this concept, last node we take as a rear. Means when we add this new node in this position, suppose okay, I write down properly. Again I tell you, suppose this is means suppose list is empty, okay, and this is a node. When you inserted in means this is empty means what? Your new node is ending, and this is also you can tell rear position, that's a start new btr, rear new btr, same thing. But this is actually in under else condition, okay, else is not written in book, that's why not there, but this is under else condition. Also you can write here else also, but books don't write here, then I don't write, but this is under else condition, okay, forgot it. Suppose this is a list. Okay, and this is rear, right? Then I erase this part. Then see, when we insert a new node, so this is a new node, new btr. When we insert a new node in here, means your now list will be now what? this null is going to what? Suppose this is this null. Now this null is in here, and your rear position will be shifted to this. Means also you can tell like that. Okay, yeah, rear will be shifted to this. Means you can tell like that, but means rear link is equal new bit here, because in previously when we don't insert a node, this is rear and this is the rear link. When we previously it will be null. Previously it will be null. After adding the new node, your rear link will now go to the new bit here. Rear link is not now null. Rear link is go to the new bit here. Your rear link is go to the new bit here, and new bit here link is, you can say, null. Means rear is equal new bit here. Now this rear is shifted to this, because this is previously new bit here. Now rear is your new bit here, and new bit here link is null. Understood? Means rear position will be shifted, and rear link will be new bit here, and new bit here link will be now null. New bit here means what? New node. Okay, that's why we use this pointer here. Rear means that at a position, at the last insertion position, means the actually last position in array. In queue, when array means this, we take this part as a rear and this part as a front. When insertion takes place at the rear position and front takes place from the, deletion takes place from the front position. Rear means at the last insertion position. Means last means at the insertion position from the back part, last part. Okay, last part. Your rear link will be now new bit here, and new bit here link will be null, and your rear will be now shifted to new bit here. Rear is new bit here. Okay. So, okay, insert the end of the list. This is the insertion end of the list. Also, one concept is I show you. So we done the algorithm for insertion in the beginning and insertion at the end. We done the program for insertion in the beginning, but the program is so much large, so that's why the program is done in the next class for insertion in the end for this topic. Okay, program is done in next class for this insertion in the end topic. I show you one concept. This concept is also important. Insertion at the middle part. Suppose this is a list. Okay. Suppose this is a list. But this is a list. Okay, 1001, okay, this contain 3. Now the element is suppose 10, 11, 12, 13. We define a node. About 17, we create a node, and 1006, right? And we insert this node at this part, in the middle part, or okay, what we take 1004. We inserted this node now in this part, middle part. Then what will happen? Now your node list will be, you say, start okay, so start contain 1001, 1003, this new node is coming 5 and 1007, means in here nothing will be changed. 103 in here 11, previously it stored 1005, now it will store 1004. Transition is in this part. And 17, in previously it will contain null, now it contain this memory address, and remaining will be same 1007 13. Means you see change is here and change is here, because when you add here, this memory address will be changed. Previously it stored this memory address, now it stored this memory address, but it is coming in the middle part. And previously it is null, now it is stored this memory address. This is the difference. Okay, but for this middle part, algorithm is not required in your syllabus. That's why I just give it a concept. Okay, because algorithm and program for this middle part, it will not in your syllabus, so I just give it a concept. Okay, in syllabus you mainly insert in the beginning and insert in the end, but this concept is essential sometimes for some purposes. That's why that's why I give you the concept. Nothing but just some memory address value will be changes like this. This will be changes to this just middle part. Mainly in your syllabus, beginning and ending will be required. Okay. So so this will be enough for this class. In next class we will discuss the program for the insertion in the end of the list, whatever we algorithm done in this class. Okay, so if you any doubt you can ask me, don't be hesitant. Thank you.